Okay, so here we go. These are the steps I would suggest you follow when you do these types of questions. So determinative order matters, right? So if it's arranging for a picture, whatever, order does matter. Or if they're specific position, then we use perms. If not, then you most likely use combination. Okay. Determine the total possible of arrangements given no restrictions. I will give this a different color because this is the one students struggle with the most. They're okay coming up with the specific, like the favorable, but the universal, it's like, wait a minute, what does that even mean? It just literally means no restrictions. If you could use all possible cases, like for making groups or passwords or you name it, it's your U. It's the greater number. Okay? I will say this. Largest number. I can't emphasize that enough. If your universal is smaller than your specific, the one that has some restrictions, then you're doing something wrong. This is all of them. This is your universal. You remember the universal set from chapter 3? It's the box that we're in. So that's the largest, and then anything else inside the largest box has to be smaller. Determine the total desired or favorable outcomes. This is when it comes specific. It's based on the conditions or restrictions that are given. This is what we call NA. So how about we give that a different color? The favorable outcomes is what I call NA. So everything is going to be find NU, find NA. And last but not least, we come up with our probability. Write the answer as a fraction. Reducing is optional, to be honest. I will not take marks away if you don't reduce, because the province doesn't give you marks for it. Okay, and they also don't take away. Decimal percent. I will say this one more time. I know it's annoying. The only reason I will reduce from time to time is if they throw a multiple choice at you. They may have reduced answers. I need you to be able to do that. Okay, and so this is what we're after: coming up with the probability. And we've already figured out NA. It's here, and NU is there. So NA is going to be the top number. So once we have those, we just need to stack them up as a fraction, and then we're good to go. So the perms and coms, that's the part that continues on from the last chapter. So let's dive in here and let's do a question. There are 4 band and 6 dance students. You know where this is going usually when it's making teams, different grades and stuff. You're like, we're probably using combinations. Okay. 4 band, 6 dance students, so we've got 10 total. A teacher would like to select a team of 4 students. Oh, there we go. Team of 4 to represent Sisler at a convention. I hope that when you see teams and there are no specific positions, that you know this is combinations. No specific positions. Roles, etc., right? So you're not worrying about that. But here it is. On the exam, on the test, you have to watch out. It's not just saying how many ways can they be arranged. It's asking for what is the probability of having a team with exactly 3 dance students. Okay, so we're going to go, it's asking for this. And NA represents the teams with 3 dance students. Sorry, it's very small, but I need to space for the rest, okay? And this is all possible teams. All possible teams. And obviously, we're always making teams of 4. Hold on. Does yours say teams of 4? Because I made a change. Yours says, your version, okay, we're good. Okay, let's do the NU part. I think that's probably the best way to start. So NU, I'm just gonna say dot dot here, like this is gonna be the work for that. If I just wanted to make teams of 4, how would you write this out? NCR. So R is 4, I think we all agree on that. What's this? Is it 4, 6, or is it 10? 10. Out of the 10, just make teams of 4. I don't care, right? If you're a band student, or sorry, dance or band, like it's all good. So that is my NU. Just make teams of 4. So we figure out what that is. I need to do that as well, because I made a change. And this is so much work. 210. 210 teams possible. Okay? Technically, we don't have any restrictions like this. Just make teams of 4, we're good. NA. Here we have to be more specific, correct? Now we're making, we have to follow that restriction. We want exactly 3 dance students. So let's do that first. Out of the 6 dance students, we're going to choose exactly 3. But there's a problem. You can't just leave it like that, because you still need 1 more, correct? To make a team of 4. So out of the 4 band students, we're going to choose 1. And let's see if we're doing this right. Am I considering all 10 students here? Yes. Do I have a team of 4? Yes. Okay. So now we go ahead and calculate that. 6C3 is 20. 4C1 is just 4. Okay. And so we've got 80. Is that correct? No. 4C1 is 4. Yeah. So that's 80. I'm just double checking something here. Yeah, we're good. So we've got 80 teams that follow the restriction that has been placed. So this is my all possible teams. This is the 80 teams that are possible that would have the 3 dance students. So probability of 3 dance. You don't have to have this, by the way. This is completely up to you if you want to do this. The bracket and say what it is. You can just say 80 over 210. And you're good. If there are trailing zeros, I would like you to cancel them out. Trailing zeros, you can cancel them 1 to 1 if they're at the end. So this should be 8 over 21. Okay. Let's turn that into a decimal. That'd be 0.38. Watch this, it's 0.95. So that turns this into 10. So that'd be 38.10%. So you gotta watch out because it's 0.95. So it's a bit of a ripple effect there. Okay, so that's where we mix up the previous unit. So it's all about stating it as a probability and breaking it down. Quite often the province is nice and they set it up for us. They're like, how many teams of 4 can you make? That's A. So you come up with something. And then B, how many teams that have exactly 3 dance students can be made? Then you do this. And then C, what's the probability? Not always, but they have done that quite often. So at least, let's say you get this one wrong, you could still get marks if you do everything else correctly. Okay? So the only exception, the denominator is always larger than the numerator. Okay? If you don't get that right, you will not get marks on the probability side of things. So come up with something that makes it bigger. You know what I mean? Like if you just cannot do it, find something. Find something. Okay. What's the probability of having at least 1 band student? There's that annoying at least 1. I don't know if you find it annoying. What is that telling us? This is not exactly 1, at least 1. So we want to get rid of all the groups that have no band students in them. Okay? So NA, we already know NU, correct? We already know NU, so we don't have to waste time on that. So we'll just say that we'll go total minus no band student. And if you do that, then you have all the ones that have at least 1, right? They could have 1, 2, 3, or 4. Okay? So total is NC4 minus no band students. So I always have to watch out for this one. So let's take care of no band students. So from the 4, we choose 0. That means that from the 6 remaining, we're going to choose all 4. So all 4 are dance students, basically, when there are no band students. Okay. So we've got that this is 210. 4C0 is just 1. 6C4 is 60, correct? I will double check that. I believe it is. No. 15, sorry. So this is 1, and then this is 15. So that's 195, right? That is NA, because remember, they asked for probability. They asked for probability here. That's why I underlined that. So we have to do one extra step. Probability, in this case, is 195 out of the 210. So because we're still in the same question, the 210 doesn't change. Okay. We can reduce that. You can divide them both by 5, but I will say this. 195 over 210, then go math, enter, enter. That is 13 over 14. Same. And you might ask, like, why didn't you talk about odds earlier? Because in my opinion, once you know your probability, odds is, I use my probability to write my odds. Okay? So C, what are the odds? What is it saying? Odds of having at least one band student. Okay, so we're basically drawing from the previous here. So I'm going to use this. Odds, right? I would go 195, right? Those are my at least one band student would be 195. And on this side, I would go 210 minus 195. That would be 15, right? Or you could have used this one here. You could have gone 13 and then 14 minus 1. 14 minus 13, I meant to say. That's 13 to 1. Either one is fine. Either one is fine. All right. Let's do one more here. How about this? I'll let you give this a try before I do it. Lots of space. So maybe let's agree. You're going to take the left side. I take the right side. And maybe you don't have to. You try, and then we try. Okay, you try. See if you can read it and try to think, like, what's the universal here? And what is the specific one? What's the NA? What's the NU? Try it. John, Ethan, and Adriana are competing with 10 other runners in a cross-country competition. Right away I can tell that 13 people are involved here. if all runners have an equal chance of winning, obviously has to be the case, or else it's no longer a true probability. Determine the probability of John, Ethan, Adriana to win first, second, and third place. What are we thinking when we see this? Permutations, right? Like it's order matter. And I say in any order, yes, but order still matters. It doesn't have to be John first, Ethan second, Adriana next, right? So maybe this threw you off a little bit. But, so it's asking for probability, okay? So watch for that. It's not just asking how many ways can they arrive, right? It's just asking what's the probability. So NA over NU, okay? This is total, basically, all ways. And this is just John, Ethan, and Ariana arriving first. So it's very specific, right? So let's do the NU first. That would be, you don't have to go equals, okay? So you can go fundamental counting principle if you want, but it's 13, 12, and 11, right? Or you can just go 13, pick 3. And that gives you 1,716 ways. NA, first, second, and third place, who are you picking from now? Like if you want to be specific to your favorable outcomes, you've got the 3 only, right? So 3 times 2 times 1, okay? Or from the 3, you pick all 3. And so that is just 6. 6 ways. Okay? I was thinking combinations. So probability here would be 6 out of 17, 16 ways. That's the probability. Okay. As a decimal, that's 0.0035. And as a percentage, very, very small percentage of that happening, but it's 0.35%. Okay, so that's what's happening there. I will do the coin one because it is somewhat of a classic, and I would strongly suggest in these scenarios to use a tree diagram. So let's do this. Fiona tossed 5 coins. The first 2 coins landed on tails. Determine the probability of the other 3 coins to have at least 3 tails. At least 3 tails. Like what's going on there? That means multiple cases, right? I will come up with the NU here. Probability is NA over NU. Okay, this is all, and this is just specifically at least 3 tails. Okay, so you have to be careful there. Let's look at it this way. For NU, I need this space for my tree diagram. So I'll just say that NU, okay, if I didn't care, the first 2 are tails. That's a given, like you can't change that. So it's 1 times 1. But then the other 3 coins, we have 2, 2, and 2, right? So what would that be in total? 2 times 2 times 2, that's 8. So we've got 8 total possibilities. And if you don't see it, you can think of it this way. We've got tails, tails, right? And then the next event can be heads or tails. So you can go heads, tails. The third coin, sorry, the fourth. This is the first, the second, the third. The fourth, heads, tails, like that. And then the fifth is heads, tails, heads, tails, heads, tails. you should be able to count 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes here possible. Let's list them all. For all of these outcomes, listen carefully to this part, right? All of these outcomes, we've got the first 2 coins are tails. That's fixed, that's written in stone. You cannot change that. So let's go TT, tails, 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 tails. Okay. And now you got to just read this chart. So we've got tails, tails, and then 3 heads here. Heads, heads, heads. For going this one, we've got 2 heads and a tail. You want me to zoom in? Sure, no problem. Okay, and then for this branch here, it's heads, tails, heads. And then it's heads, tails, tails, because of this. Then I back up here. If you go down this, it's tails, heads, heads. And then it's tails, heads, tails. And then it's tail, 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 heads. Okay. And then the last one is all tails. So this is kind of your tree diagram outlining all of the outcomes. You have 8 outcomes, right? How many of these have at least 3 tails? Let's highlight them. Okay. At least 3, so 3 or more. So you've got 1 there, 1 there. This one has 4. This one has 3. This one has 4. This one has 4, and this one has all 5. Okay. So if you wanted to know, and with coins or true and false questions, tree diagrams are very nice for that reason. In this case, you've got 7. So NA is 7. And U, sorry, I have to zoom out here a bit. This whole thing is NU, and you should have obviously more, right? NU is 8. So in this case, the probability of that happening is simply 7 over 8. That's it. All that work just to come up with that. Okay. Next, determine the probability of the other 3 coins to have landed on at most 1 head. At most means what? No more than 1. So 0 heads or 1 head. That's what it's saying. You need to be able to translate that maybe. Because at least means 3 or more. So 3, 4, 5. Okay. So let's, I don't know what I'm going to do here. I'm just going to put a dot at most 1 head. Okay. Right. So this is at most, there's 1 there. There's 1 there. Which other one am I going to pick? 0 heads, which one is that one? All tails? Is that it? Which one? This one. Yeah. Okay, good. There we go. Now we've got them all. So that's 4 out of 8. So if I already make you do a not a Venn diagram, sorry, a tree diagram, I might ask things like that so that you kind of have to just go and pick the right one. If you ever hear me say use a visual representation, tree diagrams are like gold for this particular chapter, like chapters 4 and 5. Tree diagrams are really good. And obviously a Venn diagram would also fit that criteria. I'll do one more here. Let's go to 17. I would in a contest, there are letter tiles spelling out the word Winnipegosis. The tiles are being turned upside down and shuffled. The contestant is then asked to rearrange the tiles and turn them over. What's that? Oh. There you go. Thank you. Hopefully that's not what you're going to see after the grad party, right? All blurry. Anyways, the contestant is then asked to rearrange the tiles and turn them over. And if it spells this, then you win a $10,000 cash. That's a very small prize, actually, but anyways. Determine the probability, here it is again, of a contestant winning the prize. So probability is NA over NU. Can you guess what NA will be? There's only one way to get Winnipegosis right. Only one way. You have to have it exactly like that. So there's just one way. Okay? This is the one we have to figure out. How many possible ways? All possible. Do you remember how to do that? You just did that on the test. What do you do when you get a word? You count the number of letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I get that right? I think I did. So that's 12 factorial. Can I just leave it like that? You got to get rid of the doubles, right? The repeats. 12 letters. Let's write that down. And there are 2 N's. And there are 3 I's. And 2 S's. Right? This is an aside here. You should always do that when you get a word. So we got to go 2 factorial, 3 factorial, 2 factorial. The N's, the I, and the S. If you do this, you get 479,001, 600 at the top. And here's 2 times 2, that's 4. Times 6, 2 times 6 times 2. If you do that, if you divide this, I would just make sure you put this in brackets like that. You get 19,958,400. So 19 million, almost 20 million ways. So here it is. You got it? Because normally what we did in chapter 4 is I just asked you how many ways can you rearrange the letters in that word. We would have done this, boom, right? Now the added layer is to turn this into a probability. And when it's one like this, right, there's only one way to win. And out of this many possible ways to rearrange it. Okay? This is way too small to turn it into a decimal, so we'll just leave it like that. Okay? So 1 in 20 million ways of that happening. Okay, I'll leave B. I'm not sure if I'm going to do it. It has an extra condition there. So I will ask you to try basically page 19. So write this down. Go to 19. I have more questions that I've added for you. Page 19, questions 1 to 3. And I used the textbook on this one because it is actually pretty good. We're going to spend a couple of, so pages 21 all the way to 27. I know. I don't expect you to do that all by tomorrow. I don't expect that. But let me explain to you what's happening here. you need to try these. Okay, you can't say I looked at it and it was too hard. You got to try it. I will post the key, worked out key in a bit. You got to give me, because this is brand new. But on page 27, the key, the answers are there. So I actually like that more, because these ones I know that it's sometimes like I can't do it. I'm just going to look up. Oh, okay. I want you to struggle a little bit. Okay. So on 27, I pasted in all the answers. And so sometimes that's not good enough, but. And go look at page 27 here real quick. This is actually a question here. You should recognize this immediately. This is a pathway situation, correct? But watch how this is different. What's the probability that she will pass the pool on her way to school? What would be NU in this case to go from home to school? What would be NU, your universal? Ignore the pool. You literally just have a rectangle. So you know how many pathways there are from home to school, ignoring the pool. Okay? So that's NU. NA is when you consider this your bottleneck, where you go from home to the pool and then from pool to the school. That's your NA. That's your specific case. So NU is just ignore the pool, right? Just go from home to school. NA is going, so this is kind of like two questions meshed into one. I want you to try that one as well, okay? So, I'm just going to give you the rest of the class to work, and I'll come and see you if you need a hand. I'll just leave it at that for now, okay? On page 21, can I just sneak in one more example? Page 21, question 2. Pay attention, guys, okay? So, game called Crazy Eights. Players are dealt 8 cards from a standard deck of 52 cards. Determine the probability that a hand will consist of 8 hearts. What would be NU? Out of 52, choose or pick. C or P? Choose. Yeah, we just get there's no indication that they're in order. So that's I'm not going to do the math. I'm just going to get you set up. What would be NA? What do we want? 8 hearts. So we would say out of 13, we choose 8. But it's incomplete, correct? There's still more cards. There's only 13 right now. You're in trouble. You need to have 52. So we go 52 minus 13 gets us 39. There's 39 other cards. And we're going to choose, oh, I made a 8, 0, right? Choose 0? Yeah. You might, and this is 1, by the way. This is 1, but you got to be careful. Sometimes if you don't do this, it's going to be wrong because you might have to complete the rest of the 8, right? You only choose 6, let's say, and you need to have another 2 to complete it. So I would say always think of it both ways that way. I don't know what the answer is, but you can check it on page 27, I think, somewhere at the back. But at least I got you started with that. Please practice these, okay? It is important.